The biofuel I decided to research was ethanol. Ethanol is an organic compound that is in the alcohol family. Its molecular formula is two carbons, six hydrogen, and then one oxygen. It's a major industrial chemical and it is commonly used as a solvent to synthesize other organic chemicals. And then it is also added to gasoline to create gasohol, which is pretty much gas, which is where most ethanol is used. And then the first use of it was in 1826 by Samuel Morey. And then here's just like a picture of the molecular compound of ethanol. And then it's typically made from starch-based crops in the United States. These are processed through dry or wet mill processing, typically dry. And then wet milling is when it's soaked in water to be separated, and then dry is when it's mashed up first. Ethanol is produced through two different processes, fermentation and then ethylene hydration. Fermentation is a biological process, and this is the most common way ethanol is processed, and it's how we make alcoholic beverages and gas. And this happens through the fermentation of sugar and starches of grains like corn, sugar and sugar cane, sugar beets, things like that. And then we have ethylene hydration, which is a petrochemical process. And this is the production of synthetic ethanol, which is when ethanol is used as a solvent. And then it's also made from biomass and some other sources, or like fry stalks, willow trees, switchgrass, things like that. Ethanol is widely available across the US, and the production has continued to increase. It did decrease in 2020 because of COVID, because not many people were needing gas to drive around because everyone kind of stayed home. But since then, it's continued to increase. Its impact on the carbon footprint is a positive impact. The carbon footprint is the total amount of greenhouse gases released in the atmosphere by human activities, from consumption of goods and services to the energy used in homes and transportation. So things like that is what is the carbon footprint. And then corn-based ethanol has been shown to reduce these gas emissions. Corn helps because corn helps to recycle carbon dioxide by absorbing it as it grows. So the plants absorb it as it's being released, which helps decrease the amount of these gases. And then the production of corn continues as it increases. It is shown that lower greenhouse gas emissions are produced, according to some studies that were conducted. The ethanol industry has shown to have generated $54 billion, so it has a very positive impact on the economy of the US. It also shows like good job creation, so there's lots of job opportunities in this field, and then also generation of tax revenue, and then crude oil and petroleum products also come from the production of ethanol, so it's very vital to our economy. And then its efforts to be communicated in the public, typically through like gas labels at gas pumps, social media, media in general, and then government agencies, oil industries, people just kind of trying to advertise for gas because that's like the most common form of ethanol, as I've said before. Um, that's a lot of where it's like communicated to about the public. And my current analysis for the next steps in ethanol production would be to improve the fermentation performance. Most ethanol is produced through fermentation, as I've said earlier. So if we find yeast that can handle higher ethanol concentration, that would result in faster fermentation. Because it would be able to be produced in larger amounts, which would make it be processed quicker. And so then my plan of action would be to find the fastest engineered yeast available, because the more ethanol concentration the yeast can tolerate, the faster ethanol production can occur. So if we find and use the best engineered yeast, that would be one of the best ways to increase the production and efficiency of ethanol. And then here's just a list of my citations, which will also be included in my YouTube like description box below. But thank you so much.